Hey everybody, welcome to AP Calculus Live Session 3. You are now in my very dirty upstairs room, and I am looking like I normally do on a Saturday morning, wet hair, no makeup. So let's get this started. Okay, first things first, let's look at what we're talking about today. We're talking about topic 4, interpreting graphs. You may be thinking, why are we on topic 4 when this is session 3? Well, topic 3 is particle motion on a plane, and that's for BC only, so we're not doing that. All right, interpreting graphs. There are a variety of question types. You can be given the equation of the function or its derivative and ask for the location of extreme values, intervals where it's increasing, decreasing, concavity, etc. You may be given the graph of the derivative and ask the same types of things. You could also be asked to find the value of the integral given the graph but no equation. This could be also particle motion where the velocity is given as a graph. What you need to be able to do, you need to be able to read information about the function from the graph of the derivative. This can be approached as derivative techniques or antiderivative techniques. Find and justify extreme values, first derivative, second derivative, closed interval test, first derivative test, second derivative test, closed interval test, or the candidates test. You need to find and justify points of inflection. You need to be able to write an equation of a tangent line, evaluate Riemann sums from graphs, fundamental theorem of calculus, evaluate integral from area of regions on the graph, and fundamental theorem of calculus. Realize that if g of x equals g of a, which is the starting point, plus the integral from a to t of f of t, then g prime of x equals f of x. Family of functions, functions with a parameter, functions defined by other functions. That's what you need to be able to do. So let's go down to her lovely list of what all questions recently have been on this topic. And we have done pretty much, you can see there's a lot on this topic. In class, we've pretty much done 2013 to 2011. So we're going to start with the 2010 BC, well, not BC, 2010 AB4. Okay, let me get that up. While I'm doing that, remember, if you have questions, you can tweet them to me at Barton Math. I have that up so I can check it as we're going. You can also participate in the chat on Google Hangouts. Or I think I had Q&A. I think I turned off Q&A this time, so I don't think you can do that because all I was getting last time was spammy messages and weird people. So I did not enjoy that. So this time there's no Q&A because I wasn't getting any good responses. All right, let's switch our screen share. Hey again. Let me make sure I do have the Q&A turned off. Yeah, I do. And nobody's in the chat. I have one viewer. I don't know who that is. Hi, viewer. You. Okay. What am I doing? Screen sharing the actual test. Okay. This is a Form B test, and we're looking at question number 4. You know what? Actually, we did this one yesterday because it's a particle motion one. So we are going to not do this one. Let me look at what is next. 2010 AB2 from Form B. So let's go to that one. Okay. It says the function is defined. Oh, gotta make it bigger. Learned that last night. Okay, the function g is defined for x greater than 0 with g of 1 equaling 2, g prime of x equaling sine x plus 1 over x, and g double prime of x equaling 1 minus 1 over x squared cosine x plus x 1 over x. Find all values of x in the interval 0.12 to 1 at which the graph has a horizontal tangent line. All right, horizontal tangent line. That means where the derivative equals 0. So we want to look at our derivative up here and put it equal to 0. You do need to say that's what you're doing. Oops, sorry. You do need to say, let me just close that tab so I don't open it again. You do need to say that you found these values because that's where G prime equals 0. Now this is calculator active, so you could graph this and find these values. Okay, you don't have to solve this by hand or anything like that. You're expected, when it's a calculator active question, to be able to find points of intersection and zeros with the calculator. Okay, and it occurs at these two values. On what subintervals of 0.21, if any, is the graph concave down? Justify your answer. Concavity deals with the second derivative. Concave down specifically means where the second derivative is less than 0. Again, this is a calculator active question. Now, you do have a choice here. We just probably graphed the first derivative. We can tell when the second derivative is negative by looking at the graph of the first derivative, because when the first derivative is decreasing, that means the second derivative is negative. If that's too much wibbly-wobbly, mind-bendy stuff, you might want to just go ahead and graph the second derivative and just look where is it less than 0. Okay? So, and again, once you're allowed to use the calculator. So they graphed the second derivative and said where it equaled 0, and then they said that it was concave down on this interval between those two because that's where it's less than 0. Now, look at the point values. The point values are answer and justification. This is both of those, answer and justification. This part is not necessary according to how it's divided. Okay, so you could look at, again, you can look at the first derivative where it is decreasing, or you can look at the second derivative where it's negative. Letter C, write an equation for the line tangent to the graph of G at x equals 0.3. So the graph of G, so we want to go back to the original function, or we want to look at the original function, and we want a line tangent to it. So that means we need the slope, which means we need the first derivative. To find the slope of a tangent line at 0.3, all I need to do is plug in 0.3 to this first derivative. And you can see that's what is done here. Okay? Calculator active. You don't need to do any other work. Plug it in. Okay? And then because we need an x and a y value, or we need something more than just the slope to give us a line. Specifically, we do need an x and a y value. We have our x value, but we do not have a y value. So to find that y value, we need to do an antiderivative here, going from 1 to 0.3, because we want to go from, sorry, lost my place. Yes, because we know what g of 1 is. So we are starting at g of 1 and then going to 0.3. G of 1 is 2. So we're going to have to add that to the beginning to find our current position, if you will, of the graph of G. Okay? Now, again, we are using calculators on this question. So that means you don't actually have to figure out this. You don't have to take the integral of this. You don't have to find the antiderivative of it. You probably don't want to either. So you can just type this into, well, not this. You have to actually type out the equation into your calculator and get out this value. Okay? And then my suggestion for tangent lines is always to use point slope form. Point slope form is y minus y1 equals m, which is the slope, times x minus x1. And that makes it just so easy, because all you do is put y minus y1 equals the slope that you found times x minus x1. Okay? And then lastly, does the line tangent to the graph of G at 0.3 lie above or below the graph of G for 0.3 to 1? Okay? This is a question that's asking about concavity, which is a different way of asking about it. When functions are concave up, the tangent lines lie below them. When functions are concave down, the tangent lines lie above them. So all we have to determine here is at from point 3 to 1, is that concave up or down. We already know that it's concave down at this region, and if you still have your second derivative graph or your first derivative graph, you can just look and see, is it positive or negative? And it turns out that it is positive for that region, so that means that we're concave up and our tangent line lies below it. It's best to just think about that one, to graph it out, on your calculator, and just think, where would a tangent line lie? Because, above, below, up, down, it can all kind of get messed up in your head if you're not being careful. You can do as many sketches and things as you want on the AP test. Those are not going to be graded. Those are sketches, they're scratch work. And if you're questioning whether it's going to get graded, you can always put an X through it. Anything you put an X through it will not be graded, even if it's correct. I've heard graders talk about how they saw kids who had the right answer and they put an X through it and did something else, and they really want to give them points for that right answer, but they can't because the rules say no. Okay, I will do a real quick check for questions. Thanks for that right answer. Just checking the YouTube comments, and there's nothing there. So we're gonna go on. I'll check. Let me check the chat on here. Yep, that should. We are good. Okay. So let me change my screen share. Back to here. Okay, so next up is 2010 AB5, but not the Form B. So let me go find that. I make some stupid faces. Did I say 5? Like, you could answer me. Okay. Yes, I love these kind of questions. I don't know why, but I think they're fun. The function g is defined and differentiable on the closed interval. I feel like we did this one in class. It looks really familiar. But maybe I'm just crazy. We're going to work it anyways. All right. The function is defined and differentiable on the closed interval and satisfies the equation g of 0 is 5. The graph of g prime, the derivative of g, consists of a semicircle and 3 line segments as shown in the figure above. We definitely did this one. Whatever. Find g of 3 and g of negative 2. All right. So key thing to remember is this is the derivative, not the function itself. Okay. So to find the function itself, we need to take the antiderivative. And if we just did this part, let me make this bigger. If we just did this part, what we'll be finding is the area under the curve from 0 to 3, the accumulation, how far it's gone from 0 to 3, but we need to add it to the starting point to find our current position on G. Okay? So from 0 to 3, 1, 2, 3, the area is, we have this little quarter circle instead of a semicircle with a radius of 2. So that's why we have this pi times 2 squared over 4, pi times the radius squared divided by 4, because we're looking at a quarter of a circle, plus 3 over 2, because we have a height of 3, a base of 1 in this triangle, and the area of a triangle is based on height divided by 2. So that's 3 over 2. And we have to add the 5 to it because that is our starting position. Okay? And we get that, and this is non-calculator, I believe. Yes, non-calculator. So we get 13 over 2 plus pi. You could leave it here. You don't have to simplify. You can't leave it here. This is not enough, this part, but this part is. Okay? And then for g of negative 2, we're going to do much the same thing. We're going to go from 0 to negative 2. We once again have that quarter circle. This cancels out to just pi. That's why they're just putting pi. And that's all that's in there. And you may be saying, well, why is it negative pi? That's above the x-axis. It shouldn't be negative. Because we went from 0 to negative 2, which means our limits are in the wrong order. Your limit should always go low to high. And if they don't, if you go high to low, that means you have to take the opposite of what you're doing. So from 0 to negative 2 is negative pi. Okay? And then we, of course, have to add our starting point to it. Okay? Think about it. Well, never mind. Yeah, so 5 minus pi. All right, look at the point values. Use g of 0 equal 5. So even if everything else was completely wrong, but you're using this initial value, you're going to get 1 point. You get 1 point for g of 3 and 1 point for g of negative 2. Okay, so even if you messed up that negative part here, you'd still get 2 out of 3 points, and that's not bad. All right, letter B, not number B. Find the x-coordinate of each point of inflection on the graph of y equals g of x on the interval negative 7 to 5. Explain your reason. Points of inflection mean where the second derivative is 0, where the graph changes concavity, or where the first derivative switches from increasing to decreasing, or vice versa. So, let's look. We're going increasing, still increasing. Here's where we start decreasing. So this is going to be a point of inflection. So that's at x equals 0. Decreasing, 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 we start increasing. So x equals 2 is another point of inflection. Increasing, 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 we start decreasing. So x equals 3 is a point of inflection. And that's the exact explanation they give. The graph has inflection points at 0, 2, and 3 because g prime changes from increasing to decreasing at those at 0 and 3, and it decreasing to increasing at x equals 2. Okay? 1 point for identifying the right values and 1 point for the explanation. Guys, one important thing to note is here you have to identify all three. At least in the trainings I've gone to, that seems to be the trend, is if they're asking you for, if it's multiple things and it's all 1 point, you've got to give all of them. Okay? I don't think they do half points. I could be wrong about that, but I don't think I am. All right, letter C. The function h is defined by g of x, which remember is not our graph. Our graph is the derivative of g of x, minus 1 over 2x squared. Find the x-coordinate of each critical point of h, where from negative 7 to 5, and classify each critical point as a location of a relative minimum, relative maximum, or neither a minimum or a maximum. Explain your reasoning. All right. Relative mins and maxes come from, or critical values, critical points, come from where the derivative equals 0. So I need the derivative of h. Well, lucky for us, we already have the derivative of g. It's right here. And derivatives, when we're just subtracting, means we don't really have to do anything special. We can just take the derivative of the first term minus the derivative of the second term. And this is a simple derivative. Multiply by 2, and then subtract 1 for the exponent. So our derivative here is g prime of x minus x. And we want to know where does that equal 0. So if we add x to both sides, the derivative equals 0 when g prime of x equals x. Okay? And you'll get 1 point for this right here. Okay? And where does g prime of x equal x? So where, excuse me, Okay. They have, okay, on the interval -2 to 2, g prime of x is square root of 4 minus x squared, because that's the circle part. -2 to 2, that's the circle part. So along that, this equals x when x equals square root of 2. You have solved that by setting this equal to x, squaring both sides, adding x squared to both sides. This is where I really wish I had my thing that I could write so I could show you all this instead of just saying it. I've got to figure that out because it's driving me crazy. We would end up with 4 equals 2x squared. Divide both sides by 2, so 2 equals x squared. That's where we're getting x square root of 2. Okay. The only other solution to it is when x equals 3, because we can look here. This is where x and y are equal. Okay. Is that 1, 1? That's an equal. You can just kind of look along here and see that none of these do the x equal the y. And we found, and we found the square root of 2 one. Sorry, I'm just wondering. Oh, okay. Yeah, never mind. Got it. I was wondering why negative square root of 2 would not be a solution as well, but that would be because if I plug in negative square root of 2 here, I'll just end up with square root of 2, and that will not equal negative square root of 2. So that's why. So we have 2 solutions, and that gets us another point. And then we have to decide if that's a relative maximum or minimum. And our function is greater than 0 between 0 and -2. Because we know these are the critical values, and again, I would love to see, I would love to be able to write this for you to make my sign line. So on your sign line, you should have square root of 2 and 3. And so before square root of 2, pick something like 0. And at 0, our value is 2. And so 2 minus 0 is 2, sorry. And that's greater than 0. So between 0, which is, which really this should be from -7, because that's our endpoint, right? I'm not 100% sure why that's not there. I don't know. I'm not sure why we don't have a -7 here, because we wanted to know on the interval from -7 to 5. So I don't know, but it is greater than 0 for this point, for this interval up until the square root of 2, and then from -2 to 5, pick a point. Square root of 2 to 5, pick a point. Maybe 2. That would be between those. And that value there is 0. So 0 minus 2 is -2, which means we are less than 0 for that region. So from root 2 to 5, we are negative. And when we switch from a positive to a negative, that means we switched from increasing on our function to decreasing on our function. That makes us have a relative maximum. And it's neither a maximum or a minimum at at 3. I didn't evaluate that because we need to also pick one between 3 and 5, say 4. Well, okay. At 4, it's about at 1, and so that's still going to be negative. It's going to continue to be negative, which means neither maximum nor minimum. Okay? All right, real quick check for questions. Let me switch the screen share off while I look for questions. No questions. Okay, no questions. All right, let's look at another one for this section. That was 2010 AB5 that we just did. Yeah. All right, let's do 2010 AB3. It is calculator active, and it also is accumulation. And I remember that you guys were having some hard times with accumulation functions in class, that we're getting confused by them. Okay. Let me screen share. All right, there are 700 people in line for a popular amusement park ride when the ride opens operation in the morning. Okay, that means that our initial value is 700, and I'm sure that's going to be important at some point. Once it begins operation, the ride accepts passengers until the park closes 8 hours later. While there is a line, people move onto the ride at a rate of 800 people per hour. The graph shows the rate, R of t, at which people arrive at the ride throughout the day. Time t is measured in hours from the time the ride begins operation. How many people arrive at the ride between time 0 and time 3? So 0 to 3, that's here. And so we are going to need to take the integral from 0 to 3 of this. That's what they're doing here. Okay, I would chop this up into a rectangle down here. And so we've got 800 times 3. That's not what they're doing, by the way, but that's what I would do. I've got to write something down so I can see this. Ah! A hoop on a stick. I just dropped something that I hope wasn't important. Do I even have a pen up here? Ow. Mother of pearl. It's another one of my ways to not curse when I'm teaching. All right. So 800 times 3 is what? 2,400. Okay. And then up here, let's see, we've got this little trapezoid here. Base, can't see exactly what that is. It looks like 2.5, but I don't know if I can go with that. All right. Let me look at what they did. Maybe what they did, there's a reason for why they did what they did. They added 1,000 plus 1,200. Oh, no, that's not what they did either. But I did just see something that I like, possibly even better than what they did. Ah, oops, sorry. All right, here's what I'm gonna think about, because I think I like this better than theirs. I don't know if I'm just dumb today or what, but I'm not seeing what divisions they did. So I'm going to think about it as one big rectangle, and then I'm going to subtract off these two triangles. So one big rectangle, we have a height of 1,200 and a base of 3. So that's 3,600. And then this little triangle here has a base of 2 and a height of 200. And this little triangle here has a, let's do this one. Height of 100, base of 2. So that means base height of 200. I really cannot do math in my head. Base of 2, that's 400. So that means that one has an area of 200. And then this other one has a base of 1 and a height of 400. So also an area of 200. So that means total they have an area of 400. Take that 3,600 that we had for the whole rectangle here and subtract off our two 200s or one 400, and we get the same answer they did, the 3,200. Okay. It does say to show the computations that led to your answer. But if you look at the point values, I'm not 100% sure that they graded those, because if I look at the point values, to me it just looks like they graded this part and this part. So do they mean just to show this? I don't know. I didn't grade on this one, so don't know for sure. Okay. Is the number of people waiting in line to get on the ride increasing or decreasing between time t equals 2 and t equals 3? Justify your answer. Okay, so between here and here, is the number of people waiting in line increasing or decreasing? Okay. It says that when there is a line, people move onto the ride at a rate of 800 people per hour. Between 2 and 3, there is more than 800 people getting in that line. And if the rate at which they're getting in the line is greater than the rate that they're moving out of the line, that would mean the number of people waiting in line is increasing, because people move onto the ride at a rate of 800 people per hour, and for between 2 and 3, the rate of people getting in line is greater than 800. Okay, guys, that's not really a calculus question. It's just like this section is interpreting graphs. I could ask that same question to my freshmen. They'd probably be confused as crap. But you know, the math there is extraordinarily simple. It's just saying this is bigger than 800, so that means if they're only moving people out of line at 800 people per hour, and people are getting in line at a faster rate than that, there's going to be more people and waiting in line increasing. Okay, so don't get so bogged down in the wording. Try to figure out what it is they're asking, because that's really half the battle with some of these. At what time t is a line for the ride the longest? How many people are in line at that time? Justify your answers. Okay. The rate of people getting in line only equals the rate of people getting out of line, getting on the ride, once here at time t equals 3. Okay. Before that, the rate is higher than 800. After that, the rate is lower than 800. So what that means is before this time, our wait time is increasing, and then after this, our wait time is decreasing, because less people are getting in line for the ride than are getting onto the ride. Whereas here, more people are trying to get on the ride than we can push out. Okay, so for time 0, that's what they're saying here. For 0 to 3, the rate of people getting in line is greater than 800. For 3 to 8, the rate is less than 800. Therefore, the longest line is at time t equals 3. Okay, because that's when it stops. That's when the line shifts from getting longer to remaining steady at exactly time equals 3, and then getting shorter from there. Okay, and it says that okay, so now we have to figure out how many people are in the line. So we started off with how many? 700 people. So then we already know for time 3, from time 0 to 3, we have already said that 3,200 people arrive at the ride between 0 and 3. Okay, so that's the 700 plus 3,200. But we've put some people on the ride in that time at a rate of 800 per hour, and we've been there for 3 hours. So 800 times 3 is the number of people who have gotten off the line in that 3 hours. 3,200 is the people who've gotten in the line in that 3 hours, and 700 is where we started. So if we add those up and subtract, we will get 1,500 people waiting in line at time t equals 3. That one was a little bit not necessarily hard math, just kind of mind-bendy. You kind of had to change how your mind works. So I'm going to pause for questions here. So let me just do a real quick look and see if there's any questions. Checking the Twitters. checking the YouTubes. Checking the session page. Khalid Khan asked, why does it say that the operations timed out? I don't know why it says that, because it doesn't say that for me, so sorry. I don't know, Khalid, sorry. I don't know how to help you. It's really funny to me because I plan doing this just for my personal students, and then all the comments and things I'm getting are not from my actual students, but that's okay. That's the beauty of the interwebs, I guess. Okay, so go ahead to part D. Write, but do not solve, an equation involving an integral expression of R whose solution gives the earliest time at t at which there is no longer a line for the ride. Okay. So that would oh God, that would happen when the number of people who've gotten in line equals the number of people who've gotten pushed off the line. So if we think of t as the time, as the hours, 800 times t is always going to give us the number of people who have gotten out of line because they've been put on the ride. Okay? And then if we think of the integral expression 0 to t of r of t, the integral from 0 to t of r of t, plus 700, or 700 plus that integral expression, that's the number of people who have been in line. So when those two things are equal, we should have, they switched the variable here, r of s, instead of t, because if we had r of 0 to t of r of t, we can't do that. That's not kosher. So we have to do a different variable here. So they use r of s. So when those two things are equal, that will mean that we have no one in line. When people got out of line equals the people who have gotten in line, no line. And they went ahead and solved it. I don't know that you wouldn't have to necessarily move this 800 to the other side. I think you can still leave it over here because it does not say to solve it for 0 or anything like that. You know what? No, it does say integral expression, not an equation involving an integral expression. I think you could. I think you could leave, and I don't know for sure. I've never been a reader on AP tests. I don't know if they're that picky about these things or not. But I think it would be okay to leave 800t equals 700 plus the integral from 0 to t of r of s ds. Break down the point values. 800t gets you a point, just recognizing that you need that in there. Your integral gets you a point, and the actual whole answer gets you a point. Okay? All right. Was that 3 problems or 2? I don't know. Let me check, because I've said I was going to kind of work 3 in a session unless people ask for more. I know we worked that one. Yeah, that was 3. Okay. So unless there are any other questions that I get, I'm going to sign off and go get ready for prom. That should be fun tonight. Thanks, guys, who have viewed and participated and all of that. This has been interesting, I guess, is the word for it. Yeah, so bye and have a happy Saturday. Yeah. Stop.